Before we start talking about templates, let's understand the problems we try to solve. Let's say we need a function to return the larger of two values. So here we can define a function that returns an integer and takes two integer parameters. Now here we can say if first is greater than second, return first, otherwise second. Pretty easy, we've done it before. Now what if we call this function and pass two double values? We get a warning because as part of calling this function, our double values will be implicitly converted to integers, so we'll lose precision. Now, we can solve this problem by overloading this function. So we can duplicate it, and in the second implementation, we replace all these integers with doubles. Now, the warning goes away. But what if you want to pass two string objects here? Again, we have to overload this function one more time. So over time, we'll have more code to maintain. And if there's a bug in our implementation, potentially there are multiple places where we have to fix that bug. This is where function templates come to the rescue. Using function templates, we can define a function in a flexible way so it can work with any data type. So our function will be generic. In other languages like C#, Java, and TypeScript, this concept is called generic or generic programming. So let's see how we can use a function template here. So I'm going to delete this second implementation. Now, to make this a function template, just before the function declaration, we type the template keyword followed by angle brackets. Inside the brackets, we type a template parameter, just like how we declare parameters for our functions. But the type of this parameter is not going to be int or double. It's going to be a special keyword. We can either use the class keyword here or type name. They're the same. In modern C++, we prefer the type name keyword because it tells that the type of this parameter can be anything. It doesn't have to be a class. It can be one of the primitive types. But you can also use the class keyword if that's what you prefer. Next, we need to give this parameter a name. By convention, we use a capital T. Now, we go to this function, and anywhere we have a reference to an integer, we replace that with T. So this function takes two values of type T and returns a value of the same type. Now we can call this function and pass two double values. We can also call it and pass two integers or two strings. Basically any type that supports the greater than operator. This is the benefit of function templates. We have less code to maintain, and if there's a bug in our implementation, there is a single place where we have to fix that bug. But there is one more benefit to using function templates. With function templates, potentially the size of our executable or application can be smaller. So if we don't call this function anywhere in our code, the compiler is not going to generate instances of this function template in our executable. So this is not going to be included in our executable. Now, if we call this function and pass two double values, the compiler will generate an instance of this template that takes two double values. Now, if we call this one more time, the compiler is not going to regenerate an instance that takes two doubles. It will reuse the instance that it generated for this line. Now, with overloading, we might overload a function 20 times, but we might end up only using one of these overloads. So with function templates, potentially the size of our executable can be smaller.